So we will continue with the next presentation, which will be given by Dr. Engineer Joachim Michniewicz. Sorry if I mispronounce your name.
Almost right, yeah.
Can you pronounce it for me then?
Yeah, Joachim Michniewicz. Yeah, it's no matter how you spell it, I will always listen to you.
So thank you for accepting our invitation for doing this presentation. You're from BMW and you will present something about connectivity, collaboration, and openness.
Exactly, yes. So also a warm welcome from my side. Thank you for inviting me to the event. Maybe 2 words of introduction. I'm one of the former employees of the EVB, IWB. I was there since between 2012 and 2017, and was working in the field of Industry 4.0, digitalization, reconfiguration. So I think that's why the invitation reached me in the end to this event. But after that, I of course continued my adventures in the field of digitalization and industrialization in BMW, and now I am the product owner for the platform for autonomous transport systems in BMW. So that's the control system for the autonomous vehicles in logistics in the factory. The vision here basically is to have one centralized platform that coordinates the collaboration of the different vehicle types in logistics. So you do not have these different control systems from different vendors, because normally when you buy a certain type of autonomous vehicle that's driving around in the plant, you have to buy the specific control system of that vendor too, and then you have a problem because you have to manage all these logistics control systems. You have to you have this operating effort, and also these systems don't communicate with each other. And basically what you want is a collaboration of different vehicle types driving through production, able to collaborate. So you have some kind of traffic management, you prevent collisions, and maybe even you can distribute transport orders between different vehicle types. So I will try to focus on flexibility and reconfiguration in this presentation, and show you what the strategy basically of BMW is, show you what enables are for reconfigurability here. And in the invitation to this event, there was also the question about how to use these components, how to market those in the how to market certain components of digitalization and production in the market. And I think I have some input there here too, what BMW is planning and what we are doing with the system that is currently being used in 6 BMW plants, and is being used productively all the time. It's no matter what time of the day the system is being used, and we are doing thousands of transport orders a day. So what is here is working, and the special thing is it's all based in the cloud. So that's what makes it also special, because it's the biggest and I think even first production critical application hosted in the cloud. And I also want to give some insights why cloud-based services in production are beneficial for flexibility in production. Okay, so I'll just start with what the base vision is. We are focusing here on in-house logistics, meaning basically transport in from the warehouse to the assembly line, or like transports inside of the factory. And the vision for these in-house logistics is to have like this continuous automation without structural fixed points. So that's one issue. You want flexibility by not having like to install any hardware in the factory, and the robots are able to. You can just add or get robots out of the system without having to change the hardware in the production environment. Then what I already said, we want collaboration between man and machine. So it's a bit like autonomous driving, but in a factory. So we try to learn as much as possible from the autonomous driving guys, which are also in BMW. The systems are different, different sensorics, and of course you have more control over autonomous driving in the factory than you have on the street, because I don't know, nobody is playing football in the factory floor, so you don't have to take that into consideration, and you don't expect a cow to walk out behind the corner. So you have more control, but nonetheless you need some autonomy. And what I said before, you need this ability to collaborate between different robot types. Yeah, we want minimize a small, so the complexity needs to be as small as possible. Everybody needs to be able to adapt and change the system. And what we are striving for is flexibility through individual transport. What this means is that each of the transport has a one-to-one relation. So you pick up one thing and bring it to another place, and then you drop it there. So you do not have that complexity of planning route trains with multiple transports inside of it, because a route train has 5 wagons, and then you have to plan and try to optimize how to go through the factory. But if you have individual transport, so a one-on-one relation of picking something up and bringing it somewhere, you lose all the complexity of lot building. I think that's the name for it in English. So you have to define optimized loadings for each of the route trains. So, and that's a big cost saving and a big flexibility increase. And of course, easy integration of different vehicle types and adaptation of the processes with minimal effort. I think that's also the goal here. So it's easy to change from one vendor of vehicles to another because you have one centralized control system and not this different control systems which are vendor specific. And a few enablers for that. The one thing is smart vehicles. So the goal here is to use autonomous transport vehicles, meaning they are able to localize autonomously. You do not need to put any sensors in the ground. You do not need to put any reflectors on the walls or stuff like that. All these vehicles are localized with the SLAM algorithm. So they have a LiDAR scanner, scan their environment, are able to localized without any hardware installation in the factory. That's a big feature. Then also all the vehicles have object detection, meaning they can adapt. So if they have to pick something up, they have a sensor, they understand where it's exactly positioned, they can move precisely under it, and also they can detect other vehicles, they can detect human beings. So you have all these sensors allowing these vehicles to react, and it's much easier to deploy more robots in a factory when they have more autonomy, because you don't have to adapt so many things. Another thing is the automated path planning. So the vehicle only knows where it has to go to and plans all the route itself. So all the effort that's currently a big planning effort for route trains with the planning of the paths through the factory, all that is not existent anymore. You just don't need it. And an ongoing discussion always is the relocations of functions to the device. So the more functionality you have on the robot, the better, because if you lose connection to the cloud or the system is not available for a few seconds, the robot just finishes the job. So even if there is no connection to the control system, the robot will just finish the job. So of course it won't get a new job because it doesn't know what to do. But other than that, you have much more flexibility and a much more robust system. And in the middle part, you see the ATS services. So the services are the centralized control component. So I am the product owner of the services. I am not responsible for the software on the vehicle. I'm responsible for this centralized control system. And as I said, one system for all vehicles also reduces operability costs and, as I said, allows this collaboration. And due to the fact that it's cloud hosted, it gives you a lot of flexibility, because just as an anecdote, when we deployed this system to the plant in USA, it took 1 hour. So you just use the existing infrastructure. Normally, if you would have to build up a server there, order all the infrastructure that's necessary, get the money for it, it would take weeks, several weeks to build it up. And we were able to just click on a button and say, okay, we want to host that in Microsoft Azure in North America, and after an hour it's available and people can start using it. And it's the same with getting rid of it again if you don't want to use it anymore. So I strongly believe that this cloud hosted solutions are much more flexible when it comes to that, and allow to just try something out. You don't have to invest a lot of money, a lot of time just to deploy something somewhere. It's just instantly available and people can start using it. And another important aspect is the whole front-end development and the ability to provide the users with the necessary functionalities in a really easy way that everybody can use it. I will show you how the system looks like in a video in a second, but the goal here is self-service. So that's what really increases flexibility, is when the guys in the plant can change the processes, change the missions, change how the layout of the plant looks like by themselves. Because we provide them with tools, something like a one-way zone, meaning you have a map of the factory and you say, in this zone, the robot is only allowed to go in one way. Okay, that's simple, but it's so simple that the guys in the plant can change and adapt and use that on their own. It's like a computer game. So everybody who played strategy games on a computer will feel familiar. And you see the robots driving around, and you need to provide the people with an easy UI so they can change it easily, and also provide them with tools to analyze what the system is doing. So they see which robot is the slowest, which robot maybe has the worst battery, which mission is the one that is most critical because it isn't reached in time. So having a easily understandable UI makes it really easy. And also my guys developing that system are not involved in building new missions. So if the plant wants to add new robots and add new missions, they can do it completely by themselves. They don't need the involvement of the IT experts. And that's also a big benefit. I just found out last week that in one plant they're also driving at night and added so many missions. I didn't even know that. Nobody in the team in the IT knew it because they just did it by themselves. So yeah, I think that's one of the key factors for flexibility, to make the system usable and understandable, that the people really using it can adapt the system based on their own situational awareness to the situation that they have in the plant. And then for establishment in the market, we are collaborating also with VDA and VDMA for the standardization of the interfaces to the system, like mostly the interface to the robot. And there's also this open manufacturing platform. That's a project that BMW and Microsoft and Bosch and ZF and other companies started, which basically aims at creating open source code for the IT that all the companies benefit from. So basically defining components and systems that are non-differentiating in the market and that everybody needs. So I'm the chair of the open manufacturing platform for autonomous transport systems, and what we started that like 3 months ago, and the component we chose to go open source with in the first step was this service to connect to the vehicle. So this VDA compliant component that allows you to onboard the vehicle and communicate with the vehicle, because there is a standard, there's this VDA standard. Every company like Bosch, who is building a comparable system like that, also needs this VDA system implemented. And why build it 2 times? So if they provide developers and we provide developers, and it's like an open collaboration platform to bring people together and work on components which everybody needs, that are not differentiating in the market. And yeah, that's the benefits we expect. But I will return to that topic later. I think that plays quite nicely in the topics of this day today. So of course I brought a little video, and that's like that's a presentation video from the plant. You see the robot. It's a little bit like this Amazon robot. So the robot goes under this dolly and can transport the dolly. So it can transport 1 ton. So it's quite a lot what it can move. And the robot, maybe some of you will recognize this laser scanner in the front. It has a camera in the front, so the robot is autonomous, and it can avoid obstacles. It can detect people. It can detect objects. And it plans its route itself. So it's there are dozens and dozens of robots driving around in BMW. That's one of the colleagues, and here you basically see the front end. It's in you see the map, you see some of you which might know SLAM, see that this is an occupancy map, and in that occupancy map, different zones, different objects, different points, so like charging stations and all that stuff needs to be defined. It's managed, centralized in the platform, so that's part of the map service. Here on the left, you see the main components. Maybe quickly going over it, the transport management itself answers the question, which robot does which job. So there is an optimization going to minimize basically distance driven by each robot and making sure that each transport is happening on time. So that's the transport management. We have the fleet management that's basically responsible for the things like parking and charging. So that's also central. That's also managed by the central system. Yeah, so you're able to, yeah, exactly. So you can manage the different vehicle types and manage what they do. Then you have this map service. So basically that's what you see here with the management of the maps of the different vehicles. That's also a bit complicated because for the system to really work, you need to be able to define the positions of the robots in one map. You need to know the precise position of each of the different robots, and the robots have all use SLAM, but the issue is the SLAM sensors are on different heights. So if they're on different heights, you have different maps again because the obstacles are different, and that makes it a bit more complicated. But yeah, that's working. And as I said, the people use that in self-service. And last but not least, traffic management. That's also really a really interesting topic. Basically, that's our these are our traffic rules. Something like, how do the robots behave on a traffic jam, or what do the robots do if one robot is parking and the other wants to overtake. So all these abstract rules of the behavior are in the platform, because how to put it, if there is an intersection, the robot doesn't know or doesn't see the other robot if he's coming behind the corner. So, but we know the paths of the robots, we know where they will be driving, so we have all this organization of the traffic. So these are the core services. I think I will just play the video. And yeah, you always have a live update of the positions of the robots. You know what they are doing, and yeah, that's an older version of the front end, but you have different points. You see the robot. You see if there is a dolly on the robot. You can send a mission. You can send commands to the robot. Those of you who played Age of Empires would get really quickly into it what needs to be done. And so you can manage the vehicles. You can manage the missions. There are different analytics tools also integrated, and then here you just see the robot driving through the factory, and that's like this is the drop off basically. So the robot knows the position where it needs to go, orients itself, and you will see in a second it will just drop the load. And I already said you have this one-to-one relation. So the robot only picks up one thing, and by having that flexibility, you don't need to plan any complex routes. The robot just plans each route each time in a new way. Yeah, here maybe this robot actually was also developed inside of BMW and is using the old batteries from BMW E3. So it's also ecological in a way, you could say. Yeah, exactly. There's a new version of the robot now being developed in cooperation with NVIDIA. Even NVIDIA is providing the graphic card and the camera, so it will have even more power for object recognition and stuff like that in the future. And here you see how the robot is dropping, and as soon as it gets another mission, it will just leave and continue. And maybe a short view on the system architecture. It looks like that. You have the hardware connection, you have the different vehicle types on the left. They are connected with the VDA to the services. That's, as I said, is my responsibility. And on the other hand, you have an interface to other BMW systems. So the transport orders are in SAP, meaning SAP knows that there will need a part at the assembly line. And then SAP tells us, okay, there is a transport, and we then decide which robot will do the transport. And that's like the normal flow of information, like from SAP to the ATS services, and then we choose the robot and manage the vehicles and stuff like that. Exactly. And then maybe a few words about the core functionality. So it's all cloud hosted. We really do our best to use modern technology, if it's Docker or containerization, or also using the existing platform services. So for example, we use Azure, we use Microsoft. I don't want to make too much advertisement for Microsoft, but we are using the data analytics components that Microsoft is providing. So that's also making the development much more efficient. And we have standardized interfaces, for example, to all the equipment infrastructure. That's also a really big topic. The integration of peripheral devices like traffic lights or lamps, or like the traffic lights or gates, so the robot has to be able to autonomously open a door or something like that. So there was a lot of effort in the integration of infrastructure also. But here it's the same like with the ATS, with the vehicles themselves. You need a standardized interface, you need an abstraction of communication. We're also using OPC UA here on a wide scale. And again, here we are the first production critical application in BMW using OPC UA for infrastructure connection. So that's also not bad. And also standardization to the call-off system. So SAP is is an ERP system, but there are different call-off systems like SAP and BMW. So you need to standardization also of this interface to the other to the different types of call-off systems. It's the same with the whole security topic. So we are using the different components that Microsoft and BMW are providing for user authentication, network security, and stuff like that. And also you need like other interfaces to external systems like maintenance systems. So all big production companies have big error collection systems, and also for monitoring and operations, there are also standardized interfaces to external IT systems. And currently BMW is also founding, I think like 2 weeks ago, they created a company that wants to market that whole solution. That's also really interesting. So because it's working and working well at BMW, they founded a company that will market that to other companies. So basically, let's see how far that goes. But that's from BMW perspective, that's a success story that it was possible to create a company out of competence built in IT and possibly create a business model beyond selling cars, basically, and create a business model based on competence in production. Exactly. So maybe one more word in regards to the cloud. Because it was found out that the availability of one cloud might not be sufficient, and also there was the people were afraid if one cloud is enough. As I said, we were the first production critical cloud application. The structure looks like that the solution is actively hosted in 2 cloud regions. One is in Frankfurt and one is in Ireland, and one cloud is always active. And in case one of the cloud fails, you jump to the other active cloud. So that's something that was built. It's working. And of course, it brings some complexity because all the robots and all the infrastructure are sending their messages 2 times to the 2 clouds, because you don't know which of the clouds will fail. And if a cloud fails, you don't want to lose messages. So both of the clouds are active, and both of the clouds get all the necessary messages from the different devices, whether it's the vehicles or the smart devices. And then you have something called telemetry deduplication. So you have to find out which of the messages you got 2 times. So you get rid of that. And also one thing that I think is really important is the telemetry-driven design, meaning we try not to have any states stored in the system. We just rebuild the state of the system based on the data we constantly get from the robot. So the robot sends us all the data every half second, and we rebuild the state each time based on the telemetry from the devices. So by this you prevent having conflicts in a state machine that's stored in the cloud when suddenly the state jumps from one to another. That's really important for stability and robustness of the system. And last but not least, I have one slide about the OMP. So that's the Open Manufacturing Platform. As I said, the goal here is to engage with other companies doing similar stuff and having similar problems, and together innovate and develop with inside of this open collaboration. So the goal here is to define components that are used by all companies, that are beneficial to all companies, that are non-differentiating in the market. As I said, we decided basically, if I jump back 2 slides, on this component, meaning the service for the communication from the robots to the services, because that's something that everybody needs and it's already standardized. And it's going quite well. Some companies are involved, some less, some more, but it's also a new way of collaboration, I think, in this production world, to have that open source, to have that being developed as open source. And we are committed to really bring that out to open source, to provide it to everybody in the market, and hopefully it will be downloaded by the vehicle producers, will be adapted so they can instantly start to use it. And also, of course, we are totally open to, it will be open source. So in February, I guess, or in January, it will be given out open source completely. So that's also even something that could be used by universities or whoever is interested to onboard vehicles to whatever system you want by a standardized interface. There are also other groups. I think I'm over my time, right?
Yeah, thank you for your presentation, Dr. Michniewicz. We are already a bit out of schedule. Maybe we still have time for one or two small questions before the coffee break. Thank you again for your presentation. It was very interesting.
My pleasure. Yeah.
We've got a question from Saber Darmul. You were talking about autonomous transport robots. Is there any application of intelligent projects able to make decisions on their own to influence routing, for example, like ATS will do?
I don't see the chat. I think it was stated in the chat, right?
Yes, it was stated in the chat. I think the question is about the application of intelligent projects to influence the routing of the autonomous vehicles.
Yeah, there are very many different parts of the solution where you could use intelligence, right? So like artificial intelligence, or you can use it only on the robot. So for example, they are using artificial intelligence to teach the robot how to detect objects. So something like that exists. When it comes to the mission assignment, so like this whole transport management, there is no AI or artificial intelligence in place, for example. But there are ideas to use it, but it's always a balance, because many things also work without artificial intelligence, So it's always a question of effort and result, basically. But I think, especially in the world of like pattern recognition with images or videos, there's the big potential, because there are a lot of libraries that are already that are ready to use, basically. But for the more complex topics like transport management, for example, or fleet management, like optimized assignment of parking and charging stations to robots, how can I put it? You can solve really a lot of the problems with simple rules, and this optimization effort comes at a later point. And if you design your system that you really come this close to the performance of the system, it would just be easier to put in additional robot, or add an additional charging station. So there are ideas. There are some people doing. We have, I think, 1 or 2 guys doing PhDs in that field, but currently it's not implemented. Did this answer the question?
Thank you. I think we've got time only for one question. Sorry for all the person who asked question in the chat. We hope maybe later during the day to have time to answer those ones. There is one from Tianman Ort. Can you make any statement on what are the preconditions for introducing technology like this? Concretely, I'm thinking about process standardization and lean shop floor management, but also on the IT side as to standardized ERP interface and sensorization of shop floor.
But you mean like what are the prerequisites to use artificial intelligence? You mean like in the system, or?
No precisions. What are the preconditions for introducing technologies in the manufacturing system, I suppose?
Yeah, there are many prerequisites. You need to get all the things online. You need a lot of connectivity, basically. That's like the big thing. You need to be able to connect all the components, whether it's the periphery or whether it's the robot, to the cloud. So you need enough WLAN, so Wi-Fi. You need enough Wi-Fi and enough availability of Wi-Fi in production. and I think that's one of the prerequisites. And I mean, you need all the other interfaces. You don't need to standardize them, but if you standardize them, you're able to grow the system faster. So standardization is the base for flexibility and for the growth of the system in the future. Yeah, unfortunately, I don't see the chat.
Thank you for your answers. Maybe we can.
I'll try to answer something in the chat, maybe.
Yeah, that was my idea also. So thank you for your presentation.
Yeah, my pleasure.